I've got the problem information set up here, and I just want to point out this is how you know that it's a limiting reactant problem. You have a number under each of the reactants, and I just took this from the problem, but I like putting it under like that instead of making a list on the side, because I can tell when I place things to different places what kind of reaction it is. And notice that I'm looking for something on the right-hand side, so that's a product, so that would make sense again for it to be a limiting reactant, because most of the time you're going to ultimately be looking for product. Remember, limiting reactant automatically means two sets of these strain tracks. So I'm going to go ahead and set them up so I don't forget. And I'm going to go ahead and put 1.0 grams of AgNO3 and 1.0 grams of MgCl2. And I know that I'm trying to end up with the grams of AgCl. All right, so always head towards moles. Don't think, put your unit downwards. So grams of AgNO3 into moles. And then don't think, put the unit downwards, moles of AgNO3. And then this is the point I can go lots of places. I can go to moles of something else. I could go to molecules. I could go back to grams, but I don't know why I'd want to go back. But this time I'm changing. This is the only step that I can change during. That's moles of MgCl2. Don't think, drop the unit down. Wait a second, I don't want to go to MgCl2. I want to go to moles of AgCl, because that's what the problem's asking me about. And moles of AgCl. And then these numbers come from the periodic chart, grams in a mole, but they happen to have been given in the problem. 169.90 in 1 mole. These are the coefficients, so I've got a 2 in front to 2, it looks like. See, a 2 and a 2. So I'm going to just go ahead and cancel them down to 1 and 1. And then this is also given in the problem. 143.32 grams in 1 mole. And again, you would have the look of like a bigger something and then a bigger something like initially on the bottom and then at the end on the top. All right. And then before I do my calculator, I need to fill out my other one. So I'm kind of doing all of the same thinking all at once. So I'm going to go from grams of MgCl2 into moles of MgCl2, and then moles of MgCl2 into moles of AgCl, and then moles of AgCl into grams. And then these numbers were already given, 95.2, and then these are the coefficients. There's a 2 and an understood 1, and then the AgCl is 143.32 grams. All right, now I've got it all set up. 1, I'm just going to cross the top, times 143.32 divided by 169.90. And then that gives me, let's see, I need 2 sig figs, so 0.84. I'm going to go ahead and put a few more in case I use this number later. But with 2 sig figs, that would be my grams of AgCl. And let me do the other one. 1 times 2 times 143.32, and I'm dividing by 95.2. And in that case, I get 3.010924. And if I were to round that to 2 sig figs, it would be that. But I already can tell there's a smaller number and a bigger number. This is the wrong one. This is my theoretical yield, because the small one is always the theoretical yield. The other one's like a fake number. And then I'm going to, just because I like to do this every time to be consistent, even though it's not asked every time, I go over and I label that limiting reactant, excess reactant. And I just think that's helpful.